We're going to be talking about solving systems of equations in this video, specifically graphing systems of equations. So the solution of the system will be the values of the variables which make all the equations true. Remember, systems of equations are two linear equations. We have three different types of solutions. The first solution would just be one solution. The lines meet at one point, the point of intersection. They have different slope, they're different lines. So as you can see here by the graph, we have an orange line and a green line. There's two separate lines, and where they meet is the point of intersection. So this point right there, 3, 2 would be the solution. So there's one solution. The second option is infinite many solutions. They're the exact same line, so they're the same slope, same y-intercept. As you can see, you have a green and then you have orange on top of green because they're exact same line. So no matter what you put in for x, you will always get the same y. And then we have no solutions. They never meet because they are parallel. So in this situation, you have the same slope but different y-intercepts. So the green line, you have a y-intercept of 6, where the orange line is 2. The slope's still 2 over 1. So the slopes are the same, just the y-intercept is different. When we go to graph, there's several steps we need to follow. The first step would be to solve each equation for y. Step 2 is to identify the slope and the y-intercept for both equations. Step 3 is to graph each equation and then find a solution where they intersect. The first problem we have is y equals 4x minus 2 and y equals negative 3 over 2x plus 9. In this situation, they are both already solved for y, so we just need to go right into graphing them. I have, for the first equation, y equals 4x minus 2, my slope is 4, and my y-intercept is negative 2. Remember, we pull that from the y equals mx plus b, the slope intercept one. So my b is my starting point, so I'm going to go ahead and start at negative 2 on my y, and I'm going to go up 4 and to the right 1. And I'm going to do this several times. Making sure I'm very precise on how many I go up and down. So now I'm going to go back to my negative 2 and go down into the left tool. I'm going to take and draw my line. There we go. So this is my first equation of y equals 4x minus 2. Now my second equation, y equals negative 3 over 2x plus 9. I'm going to start with my slope, which is negative 3 over 2. My y-intercept, which is 9. So this tells me to start my y-axis on 9. My slope is negative, so I'm going to go down 3 and to the right 2. Down 3 to the right 2. I could go up, but I would be off of my graph, so there's no need. I'll just do this. Then I'm going to connect my line, and where the two lines cross is where my intersection is. So right at that spot right there, which would be 2, 6. And that's saying if I plug 2 in for x and 6 in for y, my equation would be correct. So to check that real quick, we're just going to put 6 equals 4 times 2, because the 2 goes in for x, minus 2. 8 minus 2 is 6, and 6 equals 6. If we go the other equation, I have 6 equals negative 3 over 2 times 2. plus 9. That would be negative 3 plus 9, which is 6, and 6 equals 6. My next example, I have 3x plus 3y equals 12, and y equals 1/3 x. For this example, as you can see, not both of my equations are equal to equal to y. So I need to solve my first equation for y. I'm just going to go down here below, move this equation up a little bit, and I'm going to rewrite the equation 3x plus 3y equals 12. And I'm going to solve for y. First thing I need to do is get rid of that 3x. So I'm going to subtract 3x from both sides. Remember, I can't combine 12 and negative 3x because they're not like terms. 3x minus 3x is 0. 3y equals negative 3x plus 12. And I have to divide every single thing by 3. So y equals negative x plus 4. So for this equation, my slope is negative 1 and my y-intercept is 4. So I'm going to start at 4 on my y-axis, and I'm going to go down 1 to the right 1. I'm going to do that multiple times. If I go up, then I have to go to the left. There we go, I draw my line. My next second equation is y equals 1/3 x. Y equals 1/3 x. So my n is 1/3. I don't have a b. It doesn't have a constant, so my b is just 0. So I'm going to start at 0. So I'm going to go up 1 and to the right 3. Up 1 to the right 3. And go ahead. Excuse me. Go ahead and draw my line. Of course, when you're drawing your lines, you need to make sure they're arrows because lines extend forever. And then where does it cross? Where did the two lines meet? They meet at 3, 1. So that would be my solution for these two equations. Okay, I want you to pause the video and I want you to work this one out. I'm going to tell you that you need to solve for y on both problems. Once you are done, go ahead and restart the video. Alright, so now that you have solved that, let's check to see if you have them correct. I'm going to just move my graph over a little bit. Here we go. Alright, the first one I have 2x plus y equals 3. I need to solve that for y. You get that 2x on the other side, so I'm just going to subtract both sides by 2x. Cancels out. Y equals negative 2x plus 3. Then on the second one, again, I need to solve for y again. I have x minus 2y equals 4. So I'm going to subtract x from both sides. Negative 2y equals negative x plus 4. Divide everything by negative 2. So I'd have y equals 1/2x minus 2. My slope for the first equation is negative 2. My y-intercept is 3. 3, my y-axis. I'm going to go up 2 and to the left 1. And then start back and go down 2 and to the right 1. Because it is a negative slope. So the direction that you graph is important. So I have that graph. Now my second equation is m equals 1/2. My b is negative 2. I'm going to start at negative 2, go up 1 over 2. And graph it. You can see that they intersect right here, which is going to be 2, negative 1. I hope that video helps you understand graphing systems of equations a little bit better.